Good afternoon, ladies and gentlemen. Let me welcome you all and introduce myself. My name is Ahmet Bahaddin Ersoz. I'm from Middle East Technical University. I just finished my PhD in Turkey, and today I will present our research about removal of construction machinery occlusion using image segmentation and inpainting for automated progress tracking. This is the roughly outline of my presentation. Let's start with the introduction. As you all know, the accurate digital representation is crucial for project management since we can get the as-built model of construction area by using point cloud, maybe collected from laser scanners or photogrammetric technique. We can track progress accurately. But in those point clouds, we have a problem. Those are the moving objects, construction machinery. If you collect those create those point clouds by using photogrammetric techniques, those are all included in the point cloud. But if you want to track the progress, if we need change detection, compare all those point clouds to each other, those objects can create problem because they are changing their location during the construction, and each time it looks like a new progress in the construction area. Therefore, our purpose is to eliminate them, because as I said, that those create obstacles and height differences. For automated construction progress tracking, we need to eliminate them. If you look at the background of this area, this research, in the literature, there are methods those are based on the geometry, like quick slope changes and geometry-based methods. But those methods needs parameters to create terrain of the data. For example, like CSF and SMRF, one of the most used methods in the literature. If you use such methods, if you have complex topography, those methods can create holes in the point clouds and may disrupt your point cloud. Therefore, we have developed a deep learning based method. On the other hand, also in the literature, image segmentation, deep learning based image segmentation efficiently identifies segments. So why don't we use them for construction machinery? And also, image inpainting is defined as the process of reconstructing lost or unwanted parts of the images, can efficiently fill the gaps with high accuracy. Therefore, our idea is first segment the construction machinery in the images, then inpaint them, then create the 3D reconstruction of those construction areas. Let me show the flowchart of our method. First, we gather information, the 2D image information from the construction area by UAVs. Then we segment them and create image mask. By using those original and image mask, we can efficiently inpaint them, remove them from the images. If we create 3D point cloud by using inpainted images, now we have clean area that removed from the construction machinery. Let's start with the details, the image segmentation. For image segmentation, we have used our own data set called as AIDCON. It is accessible from this website, actually Aerial Image Dataset for construction. In this data set, we labeled 9 distinct type of classes. Those are dump truck, excavator, backhoe loader, wheel loader, compactor, dozer, grader, car, and one last thing is the other. The less seen machineries in the construction area also grouped under the other category. As an instance segmentation detector, we have used the point trend algorithm. We have also compared the other algorithms, but it is not in the scope of this study. For image inpainting, we used an available data set in the literature, which is Places 2 data set. In this data set, there are urban images, which are more suitable data set for our scope. That's why we have used Places 2 data set. And one of the latest studies of large masking algorithm is used for inpainting purposes. This algorithm shows prior performance compared to other ones. For real-world studies, this is our study area located in Ankara. Türkiye is a parking garage, 2-floor depth parking garage, and we have used the DJI Mavic Pro drones, UAVs, for data collection. We had flights in a fixed altitude with 40 meters. We performed 2 site visits called as T1 and T2. And we flight our drones automatically with 80% image overlap. And all those flights were autonomous to get the exactly same point cloud density in the area. So also we have collected the GCPs around the construction site to align our models to each other and also improve the quality of the point cloud. Let me show first visual results of our study. Those are the original images. First, we segment them via instance segmentation. Then we convert those segmented areas to the image masks. Then we use Inpainting to remove them from the 2D images. For segmentation results, I have tabulated the results on there. We got almost near the 90% of mean average precision, 50 IOU. And class-wise AP results in this construction area, even though we have 9 classes for detector, the only seen construction machineries are dump truck, excavator, backhoe loader, car, and the other ones. Those are the class Y average precision results. For a toolbox, we have used the open source library, Detection, for training and detecting and for also image inpainting purposes. For image inpainting, since we do not have the ground truth of those images, it is hard to find accuracy for the results. We have used the original images to get a sense of how accurate our results. We have used 3 metrics to compare the inpainted results. Those are normalized root mean square error, PSNR, and SSIM. The 0 is better for, mean square error, and the similarity index is 1 is perfect. So our result is reasonable compared to those data set to each other. For finally, we have created the 3D point cloud of the construction area. We have used our own developed software. And in this software, we have created the point cloud of the construction area. Those are dense enough to get progress tracking, almost 30 million points. And our ground sampling distance is same since we used the autonomous flight for these 2 flights. I want to show the end result of point cloud. First, I have created the point cloud with the machinery included images. Then let's see the results with the inpainted one. This is an animation, but in the back side of this research, we remove all those construction machineries from the images, then convert point cloud. In this way, there are so many applications can be performed for construction progress monitoring. Actually, I'm also working in earthwork progress monitoring. Now I can easily calculate the earthwork differences between those construction sites. This study combines the UAV imaging, machine learning, and computer vision. So our idea is to combine all these 3 fields to find a way to remove construction machinery. And we have also tested our method in a real-world construction site. So it shows a practical application for progress monitoring. The average precision scores are higher than 90% for mostly used construction machinery in the construction site. Since we are creating inpainted images separately, those images can also be used various photogrammetry software. It's all included the EXIF data of the images, and so it can be interoperable with other softwares. Future research could focus on developing an image inpainting dataset. As I introduced, we have used Places 2 dataset for inpainting. We are planning to develop our own image inpainting dataset. And one more thing is we want to increase the types of machinery we detected in the construction area. Those are the references for the ones who are interested. Thank you for listening. I can take your answers after 2 presentations. Thank you.